Hi guys, today we'll learn about multiplication of matrices. Matrix is a very powerful tool in mathematics. Before getting started with it, let us learn some basic things about matrix. So what is a matrix? A matrix is a rectangular arrangement of numbers or arrangement of numbers into rows and columns. Each number in a matrix is referred to as a matrix element or entry. Let us take an example of a matrix A with elements -2, 8, 6, 5, 2, and 7. This matrix contains two horizontal arrays called rows and three vertical arrays called columns. Multiplication of matrix with a scalar. Multiplication with a scalar. Consider a random matrix A with elements 1, 2, 3, 4, 5, and 6. If we multiply 3 with matrix A, this implies that each element of this matrix A is multiplied with number 3. This means this will be our new matrix. Now let's multiply matrix A with some random element R. So R into A is equal to R, 2R, 3R, 4R, 5R, and 6R. This was multiplication of matrix with a scalar. Now let us talk about some of its properties. Properties of scalar multiplication of matrices. Let us assume A and B are matrices of equal dimensions and C and D are scalars and O is a zero matrix. The first property is associativity. So the first property is associativity. So C into D times A is equals to C times D into A. Second property is distributive law. Second property is distributive law, where C times A plus B is equals to C times A plus C times B, or C plus D times A is equal to C times A plus D times A. Third property is of multiplicative identity. Distributed. Third identity is of multiplicative identity, where if a matrix is multiplied by 1, it remains same. So 1 is multiplicative identity of scalar multiplication. Now we'll talk about multiplication of null matrix. Multiplication of 0 with a matrix results in a null matrix, and also multiplication of a scalar with null matrix results in null matrix. Another property of matrix is closure property, where when C, a scalar, is multiplied with a matrix A, it has the same dimensions as that of A. This property is called closure property. So now we'll talk about multiplication of one matrix with another. But when is this multiplication defined? Multiplication of two matrices is defined only when number of rows of second matrix is equal to the number of columns of the first matrix. So if a matrix with order m cross n is multiplied with another matrix of order L cross K, this multiplication is defined only and only when n is equals to n. This statement also proves that suppose two matrices, let us consider two matrices, then product of A into B is not equal to B into A. Taking examples, let us take A to be 1, 2, 3, 4, 5, 6 and another matrix B to be, the order of this A matrix will be 2 into 3, another matrix B with order 3 by 3. 3, 1, 2, 3, 1, 2, 3. So A into B is defined, but B into A is not defined. Also, dimension property of matrices suggests that if two matrices with order m by n, suppose a matrix with order m by n is multiplied with another matrix of order n by k, then the resultant matrix will be of order m by k. Now let us see how we multiply matrices with an example. In matrix multiplication, each entry in the product matrix, each entry in the product matrix is the dot product of a row in first matrix and column in second matrix. Let us take an example where let us take two matrices A and B. Let A equals to A1, A2, B1, B2 and B equals to X1, X2, Y1, Y2. Let C be another matrix which is the product of these two matrices. As the number of columns in A is equal to number of rows in B, we know that A into B is defined multiplication. Also, for each element of C, for each element of C, we find the dot product of a row of A with the column of B. So our matrix C. So for our elements in our matrix C, we'll find the dot product of. So for the first element in matrix C, we'll find the dot product of row 1 in matrix A with column 1 of matrix B. So first element is equals to A1 X1 plus A2 Y1. Now the element in first row and second column. So the element in first row and second column will be the dot product of row 1 with column 2, that is A1 X2 plus A2 Y2. Similarly, these two entries will be this entry will be dot product of this row with this column, that is B1 X1 plus B2 Y1. And lastly, this entry will be B1 X2 plus B2 Y2. So we see that we have multiplied the corresponding terms of this matrix with this matrix to find element of this matrix. So let us talk about properties of matrix multiplication. Properties of matrix multiplication. Let A, B and C are let A, B and C be 3 n by n matrices I is the n by n identity matrix and O is the n by n zero matrix. The first property we'll study about will be the commutative property. Property. When we talked about dimensions, we saw that matrix multiplication is not commutative. This implies that A into B is not equals to B into A. Second property is associative property. This property says that A times B into C is equals to A times B into C. Third property is distributive property. Property A times B plus C equals to AB plus AC. Also, B plus C times A is equals to BA plus CA. Multiplicative identity property. Identity property. Here, if we multiply an identity matrix with a matrix, the matrix remains same. It doesn't matter whether identity matrix is pre-multiplied or post-multiplied. Also, multiplication with a zero matrix. With zero matrix. So, null matrix into A will be null matrix and A into null matrix will be null matrix. And lastly, this property we have already discussed, but let us discuss it once again. The dimension property. It states that the product of an M by N matrix and an N by K matrix is an matrix with order M by K. So this was all we have to do. This was all in the properties of matrix multiplication.